look at some limits involving the squeeze theorem. So given tayo ng limits, ipoprove natin na yun talaga yung kanyang limit by the squeeze theorem. So first example, we have the limit as x approaches 0 of x raised to 3 halves is equal to 0 for x greater than 0. So first, we let f of x be equal to x raised to 3 over 2 for x greater than 0. And we know that x raised to 1 half is greater than or equal to x but less than or equal to 1 for x greater than 0 but less than or equal to 1. Pwede nyo i-check ito sa inyong calculator, okay? Na kapag between 0 to 1 yung value ng x natin, true itong inequality na ito. So by using this inequality, we can multiply x kasi ang gusto natin 3 over 2, di ba? Pero we have 1 half here. So dadagdagan natin siya ng isa pa. Okay? And that is now equal to x raised to 3 over 2 is greater than or equal to x squared but less than or equal to x for x greater than 0 but less than or equal to 1. So napalabas na natin yung x raised to 3 over 2. Now if we take the limit of this inequality, we have the limit of x raised to 3 over 2 as x approaches 0 is greater than or equal to the limit of x squared as x approaches 0 but less than or equal to the limit of x as x approaches 0. Note that yung limit ng x squared as x approaches 0 is 0. Diba? Kasi polynomial lang to, pwede nating i-substitute lang yung 0. And the limit of x as x approaches 0 is equal to 0. Which means that, by the squeeze theorem, the limit of x raised to 3 over 2 as x approaches 0 is also equal to 0. The next example, we have the limit of sine of 0 as x approaches 0 is equal to 0. Observe that for all x greater than 0, sine x is greater than or equal to negative x but less than or equal to x. If you want to know kung paano ito nangyari, okay, I will link the proof below kung bakit ba naging ganito yung kanyang bound. Now, if you take the limit of that, we have the limit of sine x as x approaches 0 is greater than or equal to the limit of negative x as x approaches 0, but less than or equal to the limit of x as x approaches 0. Note that yung limit ng negative x as x approaches 0 is just equal to 0. Ganon din, yung limit ng x natin as x approaches 0 is just equal to 0. Then, by squeeze theorem, we say that the limit of sine x, yung nasa gitna, as x approaches 0 is equal to 0 din. Example number 3, the limit of cosine x as x approaches 0 is equal to 1. So for all x na element ng R, cos x is greater than or equal to 1 minus 1 half x squared but less than or equal to 1. So if you want to know kung paano naging ganito yung bound na to, meron akong proof dyan and kasama siya doon sa nakalink below. So if we take the limit of that, we have the limit of cosine x as x approaches 0 is greater than or equal to the limit of the quantity 1 minus 1 half x squared but less than or equal to the limit of 1 as x approaches 0. Note that yung limit ng quantity 1 minus 1 half x squared, since polynomial to, pwede lang nating ipasok yung value ng x. So we have equal to 1 kasi this is 1 minus 1 half times 0, kaya 1. And yung limit ng 1 as x approaches 0, syempre constant yan, so the constant itself, 1. So since 1 yung limit nito, at 1 din yung limit nito, then by the squeeze theorem, we say that the limit of cosine x as x approaches 0 is equal to 1. For example number 4, we have the limit of cosine x minus 1 all over x as x approaches 0 is equal to 0. By direct substitution, okay, we just have cosine 0 minus 1 over 0. Pero ano ba yung cosine 0? Diba that is equal to 1? So we have 1 minus 1 over 0, which is 0 over 0. This is indeterminate form. So hindi natin pwedeng gamitin yung direct substitution. So anong gagawin natin ngayon? Gawan natin siya ngayon ng paraan. Okay? Note that from example 3, sabi natin kanina, cosine x is greater than or equal to 1 minus 1 half x squared but less than or equal to 1. At na-prove na natin yan, na tama yung bound na yan. Okay? Ngayon, gawa tayo ng paraan para maging kamukha niya ito. So, anong gagawin natin? Mag-minus tayo ng 1 sa lahat. Okay? So that we will have cos x minus 1 is greater than or equal to negative 1 half x squared but less than or equal to 0. Okay? Kamukha na ba niya? Hindi pa. So next thing that we will do is we divide the inequality by x. So dividing the inequality by x results to cosine x minus 1 over x is greater than or equal to negative 1 of x. So x na lang, nag-minus tayo ng isa doon. But less than or equal to 0. Observe that for x greater than 0, this inequality is true. However, for x less than 0, mababaliktad siya. Okay? Cosine x minus 1 over x is greater than or equal to 0 but less than or equal to negative 1 half x. So actually, we are looking at two cases here. Okay? First, kapag x is greater than 0 at kapag x is less than 0. Now, tignan natin yung dalawang cases na yon. Ano ba ang mangyayari? Ano ba yung limit ng cos x minus 1 over x? So in case 1, where x is greater than 0, we have this inequality. By taking the limit of the inequality, we have the limit of cosine x minus 1 all over x as x approaches 0 is greater than or equal to the limit of negative 1 half x as x approaches 0 but less than or equal to the limit of 0 as x approaches 0. Note that yung limit na ito is just equal to 0. Okay? At yung limit na ito is also equal to 0. Which tells us that by the squeeze theorem, the limit of cos x minus 1 all over x as x approaches 0 is also equal to 0 for x greater than 0. So we have shown in case 1 that the limit of the function is equal to 0. Tignan naman natin ngayon yung case 2. For x less than 0, eto naman yung gagamitin nating inequality. So by taking the limit of that, we have the limit of cosine x minus 1 all over x as x approaches 0 is greater than or equal to the limit of 0 as x approaches 0, but less than or equal to the limit of negative 1 half x as x approaches 0. And note that yung limit nito is just equal to 0 at yung limit nito is also equal to 0. Therefore, by squeeze theorem, the limit now of cosine x minus 1 all over x as x approaches 0 is just equal to 0 for x less than 0. We have shown that in both cases, the limit of cosine x minus 1 all over x is actually equal to 0. Therefore, we conclude that, indeed, the limit of cos x minus 1 all over x as x approaches 0 is equal to 0 for all x not equal to 0. Example number 5, we have the limit of sine x over x as x approaches 0 is equal to 1. So by direct substitution, that is just equal to sine 0 over 0, but sine 0 is 0. Therefore, we have an indeterminate form. So ganun ulit, gawan natin siya ng paraan para magkaroon ng limit ito. Observe that for x greater than 0, sine x is greater than or equal to x times 1 minus 1 over 6x squared, but less than or equal to x. So itong bound na ito, na-prove din natin to, and the link is below in the description. So tignan nyo doon yung proof kung bakit ito yung kanyang bound. However, kapag x natin is negative, okay, or less than 0, mababaliktad yung ating inequality. So we have sine x is greater than or equal to x, but less than or equal to x times 1 minus 1 over 6x squared. So we are actually looking at two cases here. If we divide both inequalities by x, so for x greater than 0, this results to sine x over x is greater than or equal to 1 minus 1 over 6 x squared, but less than or equal to 1. And for x less than 0, we have sine x over x is greater than or equal to 1, but less than or equal to 1 minus 1 over 6x squared. So, kamukha na niya yung ating function. Okay? Kamukha na niya. Sin x over x na siya. Now, tignan natin yung case 1. So, using this inequality, kunin natin ngayon yung limit nito. So, we have this limit. Okay? And observe that yung limit nito is just equal to 1. Diba? By direct substitution, that is 1 minus 0 kaya 1. And yung limit ng constant 1 natin is equal to 1. Which tells us that by the squeeze theorem, the limit of this is also equal to 1. So that is for all x greater than 0. For case 2 naman, where x is less than 0, we will use this inequality. And by taking the limit of that, we have this limit. Okay? And note that yung limit nito, constant, is just equal to 1. At yung limit naman nito is just equal to 1 minus 0 or is equal to 1. So, limit nito ay 1. Limit din nito ay 1. Which tells us by the squeeze theorem that yung limit nito must also be equal to 1 for all x less than 0. And both cases showed that indeed, yung limit nga ng sin x over x as x approaches 0 is equal to 1 for all x not equal to 0. And finally, we have the limit of x sin 1 over x as x approaches 0 is equal to 0. So we know that for all z, element of the set of real numbers, sin z is greater than or equal to negative 1, but less than or equal to 1. So using this inequality, kailangan mapalabas natin ito. Okay? So we have sine of 1 over x, papalitan natin yung z ng 1 over x. So that is bounded from negative 1 to 1. And then mag-multiply ngayon tayo ng x para maging kamukha niya na ito. So we have sine of 1 over x times x is greater than or equal to negative of the absolute value of x, but less than or equal to the absolute value of x for all x not equal to 0. So observe that nagkaroon ng absolute value yung x natin. Bakit? Kasi minimake sure natin dito na magiging true yung inequality. Kapag negative yung x natin dito at wala yung absolute value dito, what happens? Okay? This becomes positive. Okay? Parang magre-reverse na yung kanyang inequality. Okay? Ganon din dito, magiging negative to pag walang absolute value. So, para i-generalize that for x not equal to 0, lalagyan natin siya ng absolute value. Pero, pwede naman, kung gusto ninyo, i-divide niyo yung dalawang cases, yung case na x is greater than 0, tapos yung isang case na x is less than 0. Okay? You will arrive at the same conclusion. But for this case, ginamitan na lang natin siya ng absolute value. So note that yung limit nung negative absolute value of x natin is equal to 0 at yung limit ng absolute value of x natin is also equal to 0, which tells us that by the squeeze theorem, the limit of x sine 1 over x as x approaches 0 is equal to 0 for all x not equal to 0.